You are familiar with the physical meaning of reducible and irreducible representations. Therefore, we will move towards to learn some mathematical tools. First, let's understand what is order and class in a point group. Order of a group is the total number of symmetry elements present in that point group. For example, in octahedral point group, there are 48 total operations. Here, you can see the total number of symmetry operation is equal to 48. So, the order of octahedral point group is 48. Similarly, in C to V point group, the order of the group is 4, as you can see here. The order of the group is represented by H. Now coming to another term, class. If two or more symmetry elements are equivalent to each other within the point group, then they form a class. Mathematically, two operations, let's say A and B, belong to the same class if and only if this condition is satisfied. Now, what does it mean? Suppose there is a function, let's say f, and we apply an operation, let's say x on it, then we apply A. Now, if we apply x inverse to it, the result that we will get, let's say f prime, if it will be equal to what we would get if we act B on the function f. Then, we can say A and B conjugate to each other, and they belong to same class. For example, in the octahedral point group, the 8C3 axis forms one class. Here, all C3 axes are equivalent. To verify this, take a function, let's say x, y, z. Select another operation from the group, say C2. If you perform C2 on x, y, z, followed by one C3 axis, let's say C31, and then apply C2 inverse, it will produce same result. When another C3 axis, say C32, applies on the same function. Here, we will say both C31 and C32 belong to same class. So there are total 8 C3 that are equivalent to each other. So, they form the same class. Similarly, 6 C2 operations, where the C2 axis passing through the centers of opposite edges, form one class, whereas another 3 C2 axis, around the vertex axis, form another class. Here the two set of C2 axes are not equivalent. When two elements are in same class, that means they transform a function in a structurally equivalent way. Not in the same way. For example, in octahedral point group, take two C3 axes, say C31 and C32. If we operate them on dxy, the C31 axis might send dxy to dz, but C32 axis might send dxy to dxz. Here, the structure means the pattern of action. Like, how many functions remain unchanged? How many functions mix? How many changes sign? So the transformation is not identical, but the structure of transformation is same. Class plays a significant role in molecular symmetry. These are the backbone of character tables. The character of reducible and irreducible representation are same for all the symmetry elements that belong to the same class. Operations in the same class always have the same character. The number of columns in a character table corresponds to the number of classes. The number of irreducible representations of the rows is always equal to the number of classes. In octahedral point group, the order of the group is 48, and they are divided among 10 classes. In C to V point group, the order of the group is 4, and here the class is also 4. As no symmetry operations are equivalent to each other, that means no conjugacy exists.